we did a 3-year seeding rate project, and I'm going to talk about the methods and results. Recently had a statistician, Ken Janovic at U of G, analyze the results. So jumping into the methods, we used farm fields that were about 100 acres in size where we could, and we divided those fields into different yield zones based on historical yields. So we labeled the highest yielding part of the fields A, and the lowest yielding parts of the field C, and everywhere in between we labeled zone B. And again, based on historical yield data, and also maybe some soil layers and conversations with the farmers about productivity across the field and what they felt accurately described those yield zones. Now with cranberry beans, we don't really have historical dry bean data because, as you know, there's no yield monitors on those large seeded bean combines. So in some cases, there may not be historical bean data as a part of creating these yield zones. Okay, then we use the enhanced learning block system, which is a program that premier cropping systems have for doing on-farm research, and it's pretty cool. You put these learning blocks in. We put one in each yield zone of the field, and each contains 15 replications, or sorry, across the field, we have 15 replications of each of our seeding rates. And so again, we put one learning block in the highest yielding part, the median, and the low. And each plot is wide enough or large enough for a combine to drive through the middle of it. So each plot is about 0.6 acres in size. So Greg Kitching pulled these seeding rate prescriptions together that kind of look like this image and plug them into the farmer's planter, and that farm cooperator went out and planted them kind of automatically. So of course, a huge thank you to Greg Kitching for all his support on this project. Okay, so the seeding rates that we used, we wanted to have, very low seeding rates so we could capture what's happening at the low end. So for white and black beans, it was 44,000 seeds, and then included kind of a typical seeding rate of 110,000 seeds, and then a little higher at 120. We wanted 3 fields per year and 3 years. Of course, something always goes wrong in field trials, so we did lose one field. The seeding rate script didn't really go down. And one grower switched to black beans partway through the project, and we decided that was fine. They're very similar to white beans, and so we just proceeded with, we have 2 fields of black bean data. These fields were also on 30-inch rows. Just so happened that the cooperators that we selected to work with who had variable rate seeding equipment, they were set up for 30-inch rows. I know a lot of Ontario white bean growers use 15s, and so maybe we just need to bump our seeding rates up about 15% to work on 15-inch rows. But again, just a reminder that it was on 30s. Okay, and then similarly on the cranberry bean side, we use very low seeding rates of 40,000. There are actually a few 30,000 in the early year of the project, first year of the project. We felt that was a little bit low, so we bumped it up to about 82,500. And those cranberry bean cooperators installed aftermarket load cell yield monitors on their combines so that we could collect yield data and create yield maps. And I've written an article about that hopefully you've seen in past OBG newsletters. And so those were installed on the picket combines. They don't measure moisture. So although we did try to adjust some of the data afterwards or clean the data, feel free to take this with a grain of salt. These are on-farm trials, and they're on-farm or the farmer's own combines, which they calibrated to the best of their ability, but we had some new technology involved. And I think the data is still really valuable and really intriguing, but of course it might not be 100% perfect conditions. So all other crop inputs were blanket rates, or they were intended to be. There were a couple growers that used variable rate fungicide, which typically just means turning off the fungicide on the headlands, for example, and is only on, say, the second or third fungicide application. So management of the fields was similar, but not the same. Some fields did have a history of manure. we conducted the project in Huron, Perth, and Oxford counties, and we used the varieties that those growers typically use. Okay, so we wanted to collect some soil data, and it was suggested to us that an easy way to, or an effective way to get whole field soil data was using soil optics. So this is a device that measures gamma radiation coming off of elements decaying in the soil. All the parameters that were measured are on the right-hand side of the slide there. I'm not going to talk about soil optics too much. You can always look into that on your own. But so we tried to see what of these field or soil parameters correlates with the optimal seeding rate on the fields. And in white and black bean fields, the only thing that really correlated was elevation. And this is similar to what some other soybean variable rate seeding projects have found. You know, I don't really know what all to say about it. It's kind of silly, like as you increase 1 foot in elevation, you can add 150 more seeds per acre. I don't know how helpful that is. There's probably other factors at play, like the more northern fields were, I think, at higher elevation, and so that may have been a factor. Not really helpful, I don't think. And it's not within a specific field. So we're not seeding one field based on elevation. That's not what this correlation was. This was across all the fields. Now, when we look within a given field, the parameter that had a weak correlation with optimal seeding rate was plant available water. And so agronomically, that kind of makes sense. If you think about a very dry conditions, you know, very dry conditions can only support maybe a fewer number of seeds, but as there's more available water, you can successfully grow more seeds. So there is some credibility to that, although it's a bit of a weak correlation in this data. It's also a little counter to some of our thoughts maybe on seeding. I don't know, in wet areas of the field, we have higher rates of root rot, we typically think. And so that doesn't translate to higher yields in maybe in some of the typical thinking about dry beans. But anyway, there was maybe a weak correlation there. On the cranberry bean data, there was none of these soil parameters correlated with optimal seeding rate. And so, you know, we could talk about other ways that we could measure soil parameters or other ways of seeding according to soil parameters. But, you know, based on this data, what did we learn about what in the soil drives our decisions about seeding rates in a variable rate seeding scenario? We didn't really learn much. Okay, in terms of emergence results, these are kind of interesting. So on the black and white bean fields, as you increase seeding rate, we had higher rates of emergence. And I've heard dry bean growers say that before, so it was kind of cool that we were able to measure it. You know, at very low seeding rates, only 74% emergence, and up to kind of a maximum average of 84% emergence. On the cranberry bean side, it didn't quite shake out the same way. Surprisingly, I thought, you know, in crayons, it might be more important for them to push together, but we weren't really able to see that in the data. Emergence ranged from actually fairly low at 65% up to 90%. Sometimes emergence was better at higher seeding rates, maybe up to 16% better at the higher seeding rates. But other times it was the same regardless of, or sorry, for both low and high seeding rates. So not a whole lot of interesting results on the crayon side in terms of emergence. Now, if we look at the zones and the yield results on each of these different yield zones in the field. So again, A is where we anticipated our highest yields. And C is where we anticipated our lowest yields, although bearing in mind we didn't look at headlands. So on the white bean yield results, we actually, the yield in the zones didn't really match what we anticipated. We didn't really accurately estimate, you know, which parts of the field would yield better. Sometimes the C zone was actually the highest yielding in our project. at least in a couple cases. Sometimes the whole field kind of yielded the same on average. So we're not that good, at least on this project, in kind of assessing where we would have the highest yields. And if you think about, if we're going to go VR seed a field based on historical yield, well, it's not going to make sense if we don't actually know what areas of the field yield more. But anyway, so if we look at what was the optimal seeding rate in each zone of the field, sometimes, a blanket seeding rate was best. It was the same in all parts of the field. Sometimes the optimal seeding rate in one part of the field was 75,000 seeds more than the optimal seeding rate in another part of the field. So quite a range across these white bean fields. When we think about the cranberry bean fields, in terms of yield results, we actually were better at predicting what the anticipated yield would be. In most of the cases where we said this is the A zone and we'll have the highest yield, that was in fact the result. And so it's interesting. I wonder if this is maybe because we didn't have historical bean yield data, maybe that what the grower's own knowledge about the field was more accurate than some of the old data. I really can't say why it is. Maybe it had more to do with the location and the specific fields that were used. So when we look at what was the optimal seeding rate for cranberry beans in each part of the field, in the crayons, there was always a part of the field that had a good response to changing seeding rate. So as we increased seeding rate, the yield changed significantly, which wasn't really the case in the whites. In the biggest difference was we had a field where one part of the field needed 38,000 seeds more than another part of the field to have an optimum seeding rate. But the average was closer to, I think, 12,000. So you think about variable rating your crayons, there's about on average, 12,000 seed per acre range across which it kind of made sense. That range for white beans averaged around 40,000 seeds. So it's kind of hard to explain and think about, but hopefully you can kind of see what I'm driving at. But when we look at some specific field data, hopefully it becomes a little more clear. So orient you to the chart here. We have seeding rate on the horizontal axis and net return on the vertical axis. So in terms of net return, we just use like OMAFRA numbers for crop inputs. So this is the part that's not actual on-farm data, but is standardized across all the fields. And then we use the actual cost of the seed. So that's the only cost that changes, is the cost of the seed as we change the seeding rate. Okay, so this is one of the black bean fields, but more or less represents what we saw in all of the white and black bean fields. And as you'll see, for starters, this is one of the cases where the C zone that's supposed to be the lowest yielding zone wasn't the lowest yielding zone. So we'll start at the bottom curve here. There's a red dot in that B zone, and that is where we have our maximum return. So at the lowest seeding rate, which in this case was 55,000 seeds, as applied, that's where we had the best economic return. And as we increased our seeding rate, yield did not increase. And so all we did was lose money the more seed we put out. Now, this green area of the curve, and I apologize to anybody who's red-green colorblind, is showing us that up to about 70,000 seeds per acre, that's within $10 of the maximum return. So between about 55, or maybe it's 58 there, up to about 70,000 seeds. That's kind of the wheelhouse for that area of the field in terms of max return. Now, if we look at the next curve up, the C zone, the max return was achieved with a seeding rate of about 78 or 80,000 seeds per acre. But there's actually quite a wide range across which we're very close to that max return. We're within $10. So anywhere from 55 to 95,000 seeds per acre, you're pretty much, you're right in that neighborhood of max return. And then if we go up to the A zone, so in this case, it was the highest yielding area of the field, and we had our best return with a seeding rate of just over 105,000 seeds per acre, which is close to the OMAFRA recommended seeding rate on 30-inch rows. But again, quite a wide range of about 75 to 125,000 seeds per acre. That wide range, anywhere in there, gets us within $10 of the maximum return. So in the white and black beans, we had a lot of flexibility. Maybe they have more flexibility, kind of like soybeans, than we gave them credit for. Across a wide range, we're getting good yields. We don't have to necessarily narrow in on specific seeding rates in these zones to have good or the highest return. These green areas of the curve are also overlapping. So it's a little easier to imagine, if you look at this data, that we could pick one seeding rate that would kind of satisfy all of these areas and put us right in that zone of nearly maximum return. Okay. Now, similar data, same kind of graph for the cranberry bean data in one field. And again, this more or less represents all of the cranberry bean fields, or what we saw in each of the cranberry bean fields. So for starters, like I said, we were better able to predict which area was the top yielding in the cran. So the A is the highest yielding and the C is the lowest. So in the C zone, in the lowest curve here, right around 65,000 seeds was our max return in that tougher or lower yielding part of the field. And that green area of the curve is much narrower. So we have to be a little more exact on what seeding rate we pick in each of these zones. So each of these curves have a narrower green area. And you'll also see that there's not a lot of overlap in the green areas. So in the crayons, it's harder to pick one seeding rate that kind of satisfies the best return across the whole field. And the other thing that's different in this, at least in this specific field compared to the previous chart I showed you, is that here, you know, this kind of aligns with the typical thinking with variable rate seeding, that in our best yielding parts of the field, we can lower our seeding rate, and that will give us, we can still reach a maximum yield potential with a lower seeding rate. Whereas if we go back to the white bean data, it was kind of the opposite. Like, we needed higher rates to reach maximum return in the best yielding parts of the field. So yeah, it's just there are some differences between the whites and the crayons, and a lot of this is driven by, especially the narrower green zones, is driven by the fact that cranberry beans are, you know, 2 or 3 times more expensive than the white beans. And we'll also see that overall the seeding rates are much lower than what we would typically have recommended as seeding rates in cranberry beans. Okay, so we look at yield or variable rate by yield zone versus a blanket seeding rate. In the white beans, let's not focus on the number, but in this project, we were making about $600 per acre when we picked the one optimal seeding rate for the whole field. Now, if we looked at that graph and picked the 3 best yields for the 3 optimal yields for the 3 different yield zones and seeded the field that way, we gained about $7 per acre. So that's not very much. It kind of tells us that in the white beans, there's probably not a lot of advantage to investing in VR equipment if we don't already own it, and trying to figure out what is the best yield or best seeding rate in all these different areas of the field. Now, this does assume that the A zone represents 1/3 of the field, the B 1/3, and the C 1/3. And so that's kind of the easiest way to kind of analyze the data. Of course, it's not a reality in a field necessarily. Hopefully you have smaller parts of your field that are low yielding. And so that would change how this shakes out, but it's kind of hard to go through all those different scenarios and assess them. And so $7 on average was the advantage to variable rate seeding. Now, there was one field where we could, using those optimal seeding rates for each zone gave us $21 more per acre. But again, on average, it was much lower than that. And so if we look at that, what was the optimal blanket seeding rate? Forget all this VR stuff. What's the optimal seeding rate in white and black beans? At 7 of the 8 locations, if you seeded between 88,000 and 94,000 seeds per acre, you were right within that maximum return. And so that's 7 of 8 locations. On one other location, it was a dry location, and it was low yielding, and it was the lowest seeding rate was the most economic. And I would never recommend you seed 44,000 seeds per acre. So if you look 88 to 94,000 seeds per acre, that's again a little lower than what, say, the OMAFRA recommendation is for white beans on 30-inch rows. Now, in this trial, we measured 84% emergence at that approximate seeding rate. And so we're really only talking about 75,000 plants per acre in the field, which is, just thought I'd mention to think about in terms of a replant scenario. It's only 75,000 plants per acre that's optimizing our returns. And so, maybe in terms of a replant, that's interesting to think about. And again, as a reminder, this is 30-inch rows. And so if we're talking 15s, we probably need to adjust up about 15% to that seeding rate. And again, this trial was conducted in Huron and Perth counties. So lots of beans grown in that area. But in my opinion, as you move into shorter maturity areas, it's probably less beneficial to start reducing your seeding rate. So the lower the seeding rate, the bigger the bean plants, the more branches, and the longer it takes those branches to mature. They'll be green a little longer in the season. And we see this with canola as well. So in shorter maturity areas, you could run into slower maturity. Although, well, I have a photo. This is in North Perth County. You can see 44,000 seeds on the right-hand side in September is still pretty green, but at our highest seeding rate, they're not really green anymore on the left-hand side of the photo. So again, I'm talking 90,000 seeds, I would never recommend 44,000 seeds, but it is kind of an indication that we could run into maturity issues, and of course, variety is a factor here. Okay. So now cranberry beans, a variable rate by yield zone versus a blanket seeding rate. Our optimal seeding rate, at our optimal seeding rate for the whole field, we're netting about $1,400 per acre in this study. Now, the actual number in my trial is maybe not real or not super important. I will say we had a couple exceptionally high yielding cranberry fields in this project. If we go to that graph and pick the 3 optimal seeding rates for each zone and seed those, you gain about $18 per acre. So it's certainly a little higher on average than what we saw on the white beans. Maybe this says there's a little more room to make money with variable rate seeding with cranberry beans. Again, it's difficult though to figure out which seeding rate is appropriate for each part of the field. So, and again, this data assumes that the A zone is 1/3 of the field, the B zone 1/3, and the C zone 1/3. Now, in this project, we had some fields that didn't have 3 zones or only had like 2 of the enhanced learning blocks. And so in those cases, it's half the field and is the A zone and half is the B zone. But anyway, on average, gaining $18 per acre if you variable rate. In this project, there were 9 fields that had multiple zones. And in 3 of them, we actually had pretty good returns with variable rate seeding in theory, up to $35 an acre. So, maybe that's worth pursuing. But in 3 fields, it was more moderate, $13 to $18. And in the final 3 fields, it was fairly low. And so what is the optimal blanket seeding rate in this project for cranberry beans? If you average across the 11 locations, the optimal seeding rate was 54,200 seeds per acre. And indeed, I think the growers on this project are actively kind of reducing their seeding rates because it's showing they've seen that it's more economical. And so we do need to bear in mind, I didn't say that you get more yield with 54,000 seeds versus other seeding rates, but the return on the investment in that expensive seed and the yield that you get out of it is maximized at this seeding rate. At this seeding rate, we measured about 78% emergence. And so what we're talking about is only 42,000 plants per acre. So again, I just thought I'd throw that up there in terms of when you're doing stand counts in the field or when you're considering replant scenarios, it's not a lot of plants. And it did look pretty thin in these plots in the low seeding rates, especially early on in the season. Now, again, this was only done in Oxford County, good bean ground. For sure, there was a variety of soil types and soil parameters involved in the project, but the fields were relatively close together, geographically speaking. And I know we grow a lot of crayons further north. And again, I believe as you move further north, when you lower seeding rates, you get more branching. Those branches might take longer to mature. Now, just a final couple slides. In terms of weeds, there was a couple, the one farm that had the most weeds, generally speaking, I did see more weeds in the low population plots. These are white beans. It happened, I would say, yeah, across the field, 1 year, every low population plot, so 44,000 plants, there were more weeds, and you can kind of see it in the background there. But for the most part, beans aren't big enough to shade out weeds early in the season. We just don't get canopy cover. And so I don't think it's going to be a big part of our weed control. And again, you know, I'm not suggesting seeding at 44,000 seeds. So I don't think we'll see huge impacts on weed control. In terms of white mold, it was very cool to see in one field out of all of the white and cranberry and black bean fields, there was one time where the higher population plots had more mold than the low population plots. And I could see it in multiple replications, and that was very cool, but it was only one field. For the most part, what I observed was that yes, more lush growth and thicker canopies equals more mold potential. But what causes thicker canopies is not necessarily population. It's early season vegetative growth. It's where we have lots of rain early in the season, the plants get big early on, or you know, where we have manure that is encouraging, or high fertility that is encouraging those plants to get big early on. So again, population, I don't think is a big factor, generally speaking, in white mold. And that's all I wanted to say. And I hope that you found this interesting, and I hope to put some reports together and share this with you. Huge thank you to all the dry bean growers that participated in this project, and to Greg Kitching, who was a big part of making it happen, as well as Nicole Rabe and Dan Bahari at OMAFRA, and Ken Janovic at the University of Guelph did all this awesome data assessment and made these fancy graphs. And our funding partners are there. Thank you so much, and have a great day.